Welcome pre-kindergarten and kindergarten students to the Dallas Independent School District STEM Environmental Education Center. I would like to give a special welcome to a number of schools this afternoon. The first school is David G. Burnett Elementary. The second school is Johnston McQueen Elementary in Longview ISD. The third school is Marcus Elementary. Then we have Sinclair Elementary from East Central ISD. Next, we have Bush Elementary from Dallas ISD. And last but not least, we have the girls from the Solar Preparatory School for Girls right here in the Dallas Independent School District. Thank you all so much for joining us this afternoon. We wish you could be here in person, but since you can't be, we're going to do our best to make you feel like you're here during a virtual field trip this afternoon. If you are watching this and have not registered for this field trip yet, you can still do that by going to www.tiny.cc/EEC register. Once you get there, you can get yourself or your class registered for this field trip. We just use that information for our attendance purposes. Today's field trip is going to be all about properties of rocks. During this virtual field trip, students will discover that the natural world includes earth materials. Students will observe and describe rocks by size, shape, color, and texture. So first, you're going to see me use some tools to study rocks. Next, we're going to look at the color and texture of rocks with Mr. Ramirez. Third, we're going to do a scratch test and more with Mrs. Fuller. And last, you're going to see if rocks sink or float in water with Miss Nash. While we're doing all of that, you can ask us questions, but since this is a virtual field trip, the way you ask a question is by going to this website, which is www.tiny.cc/EEC-question-answer. Once you get there, you'll fill out a very short form to ask us any questions you have related to properties of rocks. You can ask as many questions as you like, and we will do our best to answer all of them in the time that we have with you this afternoon. So let me stop sharing this screen here, and I'm going to switch to another screen to start off with using tools to study properties of rocks. So it's just going to take me a second here to get my iPad linked up to my laptop so you can see it. We're almost there. There you can see it. And let me get my camera turned on. There we go. So you can see I have 5 rocks sitting on my desk. The first rock is fluorite. The second rock is granite. The third rock is calcite. The fourth rock is sandstone. And this last rock here is lodestone. And you can tell that they don't all look the same. They have some properties, and I'm going to record some properties and use some tools. So the first tool I'm going to show you is actually my science notebook. So you can see I titled this table here, Properties of Rocks, and I've named my rocks fluorite, granite, calcite, sandstone, and lodestone. And we're going to look at the color of them and some other details of them too, which brings me to my second tool, which is a hand lens. So I've got that in a little holder right here. So there it is, my hand lens, and I'm going to stick this in front of the iPad here so that you can see it. And let's take a close look at our first rock, fluorite. There it is. It's kind of a greenish color. It has some crystal structure to it, a little bit shiny, some white in it as well, and some black. And sometimes, nope, that's not going to want to work today. So there's fluorite. It's kind of an interesting, pretty rock. Next, we have granite. And this is called pink granite. And you can see that it has a pink color to it. There's also some black. And as I turn this around, it sort of twinkles because it's got tiny little crystals in it. Their crystals are much smaller than the fluorite crystals, but they are crystals nonetheless. So again, that's the pink granite. And then next we have the calcite, which is a white rock, and it has some crystal structure to it as well. Kind of sparkles or shines. Not all of it is pure white, but it's mostly white. It's not the most pretty sample of calcite there is, but it is calcite nonetheless. So there is some calcite. Next is sandstone. You can almost see little grains of sand in this rock because it is made up of sand. That's why it's called sandstone. And last is lodestone. It's black. You might notice some little pieces kind of sticking off of it like that. I'll explain what those are in a little bit, but I don't want to explain just yet. But again, that is lodestone. So there we have used the hand lens to take a careful look at those 5 rocks. So I'm going to set that aside now and get my notebook back out. Let me find the pen I just dropped. Well, I'm going to have to get a new pen. All right. So we're going to write down the color of these rocks. Fluorite has kind of that green color to it. So let me write down green for fluorite. There it is. Fluorite is green. And next we have granite, which is kind of that pink color. See if I can get that to focus in on it better. There we go. So I'm going to write pink for granite. Just like that. And then next we have the calcite, which is that white color. So I'm going to write white for calcite. And then we have sandstone, which is kind of gray to me. So I'm going to write gray. And then last we have the lodestone, which is black, almost pure black. So let me write black here. So there I've got that first column of my notebook completed. Fluorite is green, granite is pink, calcite is white, sandstone is gray, and lodestone is black. Now it's time to check and see if they are attracted to a magnet or not. Or another way to say that is, are they magnetic? So here's my horseshoe magnet that I'm going to use. You can see that, well, no, it's right on the bottom too. Sometimes the magnets are exposed on the bottom, but they're inside the plastic. And if I touch the magnet to fluorite, it is not magnetic. So let me write that down. That's a no for fluorite. It is not magnetic. How about granite? Is granite magnetic? It does not seem to be attracted to the magnet at all, so no. How about calcite? Again, no, it is not attracted to that magnet. How about sandstone? Again, no, not attracted to the magnet. How about lodestone? Well, that one, yes, the magnet picked it up. So lodestone is magnetic. It is attracted to that magnet. I'll even kind of pull that back off of there and set that back down so I can now record these observations. So granite was a no, calcite was a no, sandstone was a no, lodestone was yes, attracted to that magnet or magnetic. So there is the property of magnetic, and now we're going to do the property of mass using a pan balance. So I'm going to get these rocks out of the way here. Get that magnet put away and take out my pan balance. Oh, and let me get my camera turned back on. There we go. So there you can see the pan balance. Let me move that just a little bit closer. And it is about perfectly balanced because this triangle is pointing at this line. And you could use a pan balance a couple of different ways. One way is to take two rocks and compare them. So if I put the granite on this side and the sandstone on this side, you can see that granite is heavier than sandstone because the granite went down and the sandstone went up. So that means granite is heavier. But I don't want to just compare rocks. I want to measure the actual mass of these rocks. So I'm going to use some mass pieces. So this is a 10-gram piece of mass here. We use grams to measure mass. It's kind of the bigger one. I also have some 5-gram pieces. They're a little bit skinnier. They're only 5 grams. And I have some blue ones that are only 1 gram. You can see they're really skinny. This only weighs 1 gram. So I've got my pink granite there. Let me add 10 grams and see what happens. Nothing happened. It didn't balance yet. So let me try another 10. So 10 plus 10 is 20, 30, 40, 50. Whoop. It went too far down. So I'm going to take 10 back out. So 50 minus 10 is back to 40. Let's try a 5. So 45. I can see it's getting closer. So maybe we'll just try ones now. So we have 45, 46, 47, and there it balanced. So I know the mass of my granite is 47 grams. So I recorded that in my notebook. I think that's all the time I've got for doing these. So I did pre-measure these. So my calcite was 51 grams. The sandstone was 11 grams. The lodestone was 104 grams. The fluorite was 53 grams. So if I were to measure all of those, it would look like this. And I did that ahead of time because I knew I wouldn't have time to get all of this done. So that is using a science notebook to record properties of rocks, using the hand lens to carefully observe rocks, especially for their color, using the magnet to see if they're magnetic or not, and using the pan balance to measure the mass of each rock. Let me check if there are any questions here. And the one question that came in is, are there any other tools that you could use to talk about the properties or describe properties of rocks? And yes, you could use a ruler. So if I take my ruler here, my piece of calcite, and I measure the length of this calcite, you can see that it is about 3 centimeters long. So that's another tool you could use to tell about the properties of the rocks. All right, now we're going to look at color and texture of rocks with Ms. Ramirez.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be looking at the color and texture of rocks. So for color, we can use our eyesight to help us determine color, and you guys are probably familiar with some examples of color ranges. We'll look more in detail at these different colors in just a second. So for color, we're going to look at the different birthstones. So birthstones are just the rocks or minerals that represent the month that you were born. Now, these rocks and minerals can come in a variety of different colors, and sometimes either your parents or yourself, you might have rings or earrings or some sort of jewelry that has your birthstone in it. So let's take a look at some of the colors that birthstones can be. So what color is this? So if you were born in the month of November, go ahead and raise your hand. If you were born in November, your birthstone color is golden topaz, and it looks like this beautiful gem right here. So again, this color is yellow. Let's take a look at our next color. So what color is this paper? So this paper is white. And if you were born in April, go ahead and raise your hand. Your birthstone is the beautiful diamond, and you can see that sparkling diamond here. So that is the color white. Now let's take a look at our next months. So if you were born in January or July, go ahead and raise your hand. And if you were born in January, your birthstone is the beautiful dark red garnet. And if you were born in July, you have the beautiful red ruby as your birthstone. So birthstones can be red as well. Let's take a look at our next color. So what color is this paper? So this is purple. And if you were born in February, June, or October, go ahead and raise your hand so we can see your birthdays. If you were born in February, your birthstone is this light purple amethyst. If you were born in June, like me, your birthstone is alexandrite, and it's this purple pink stone here. And then if you were born in October, like my mother, you have this light purple tourmaline gemstone here. So this is the color purple. Now let's look at May and August. If you were born in May and August, go ahead and raise your hands. If you were born in May, your birthstone is this dark red emerald. And if you were born in August, your birthstone is this beautiful light green peridot. So gemstones can be green. And then our last one, if you were born in March, September, or December, go ahead and raise your hand. And happy birthday to you, December folks. If you were born in March, your gemstone is this light blue aquamarine. And if you were born in September, you get the beautiful blue sapphire gem. And then if you were born this month in December, your birthstone comes in a variety of different colors. We have that dark blue tanzanite, that middle blue color, zircon, and then turquoise. So we know that gemstones can also be blue in color. So sometimes people just think of rocks and minerals as being brown and black, but they can come in all sorts of cool colors. So that was colors. Now let's talk about texture. So we can use our hands to help us feel texture. And texture just tells us how does something feel. So let's look at our first texture word. Textures can be bumpy, spiky, and sharp. So think of some things around your house or school that might be bumpy, spiky, or sharp. So let's look at one of our rocks. Think of the colors that you see both in the inside and the outside, and think of textures. How do you think this rock might feel? So I can tell that this rock is a nice shiny white. It looks like white crystals. The outside is a light brown. The outside is rough. And the inside is bumpy. And there's also some sharp pieces in there as well. This is quartz, and it's a beautiful type of mineral. Nice and shiny. So let's look at our next one. So look at this one. What colors do you see, and how do you think it feels? What is its texture? So I can tell that this one is a nice golden color, or dark yellow, or bronze. And this is called iron pyrite. It's also known as fool's gold because people think it's gold, but it's not real gold, so I'm not rich. But if you were to touch it, it does feel super rough and bumpy. And some of these feel like a block. So that's pyrite. This is one of my favorites. I love the shiny stuff. So this is a type of quartz, and it has lots of different colors in there. Can you name some of those colors? And it's also super shiny. So some of the colors that I see are blues at the tip. I also see purples, yellows, and that beautiful gold color as well. This one also feels bumpy because I can see, and I can also feel those bumps on it as well. And then another one that we have, this next rock is going to be rough and chalky. So take a look at this one. It's a nice white rock. You guys can probably find this in your yards. When you touch it, it leaves a white powder on your hand, sort of like when you're writing with chalk, it leaves that powder on your hands. So what do you think is the opposite of bumpy or spiky? So our next few rocks are going to be smooth or glassy. So let's look at this cool one here. This is a mineral, and it's called gypsum. What color is it, and what do you notice? So I can notice that it is see-through. I can put my hand behind it and you can see it. Also, if I touch it, it is rather smooth. It does have some edges, but for the most part, it's pretty smooth. And then this one here, this one is a nice black rock, and it's also shiny. It's also very light. So even though it's big, it feels super light. And it also has some smooth or glassy surfaces. It feels really smooth, like if I were to touch a bottle of glass. So those are textures. Now what I'm going to do, I'm going to share my screen with you guys, and we're going to take a look at some more rocks using a special microscope. So let me just start my screen share with y'all. So we already saw some examples of texture. So these are just some texture words, and these are some color words that you can use for review. In case you missed it, your birthstones, this slide just goes over a review of your birthstone colors. And then you might have heard me use the words rocks, minerals, and gemstones. So rocks are made out of minerals. Think of when you eat a cake. That cake is made out of different ingredients like milk, butter, and eggs. So just like that cake, rocks are made out of different stuff too. So rocks are made out of smaller things called minerals, and those minerals are made out of even smaller things called elements. And then you notice I use the word gemstone or birthstone. That's just another word for fancy minerals, and those gemstones are usually minerals that people use for jewelry because they look so pretty. So here's a close-up of a mineral called peacock chalcopyrite. How do you think it got that name? So it got the name because people thought that the colors reminded them of the feathers of a peacock, and that's this bird that you see here. So what are some colors that you guys notice? So I can see these pretty purples and golds and the blues and the greens. This is another one of my favorite rocks and mineral. Here is agate. So what are some colors that you guys see? So we have some reds, a little bit of white, some blacks and browns. Our next one, I don't know what this one is. I found it in my backyard, but it sure was pretty. It has these cool little stripes going through it, and it was this pretty blue-green color. Our next one is malachite, and it's a mineral. So look at that cool blue-green color. And then there's also some brownish red going on too. This one was super cool. This is sulfur, and it is a bright yellow color, and it's a type of mineral. It's also an element as well. And then here's a rock collection that we have. Think about what colors do you see, and how do you think they might feel? So if you were to look at these, maybe pick your favorite one and see if you can describe its color. And then our next thing, some rocks actually glow in the dark. So you can see in this video, in this image here, I have some rocks under regular light. They don't look that fascinating, but when you turn the lights off and you put this special flashlight over them called a UV light, it makes those rocks glow in these crazy neon colors. So I'm just going to show you just a quick little clip of this video. It's from Magic Rocks, A Journey into Fluorescent Crystals. So you can see how these rocks glow and turn these cool neon green, orange, pink, and blue. So some of these rocks are super cool. And you can look at that on your own time with an adult's help. It's a pretty cool video. And my next thing is, well, why do we care what color rocks are? So rocks are super important because animals use them for shelter and for their home, and they can also use it for protection. So animals have what's called camouflage. Camouflage means that their fur or feathers is the same color as the background. So look at this picture here. Can you guys find the 3 sheep and a snow leopard? So the 3 sheep are these animals that have horns on them, and then there's a snow leopard. It looks like a cat. So see if you can find those 4 animals hiding in this image. Now I'm going to go ahead and show them to you to help you guys out. There's 1, 2, 3. So those are our sheep. And then there's a snow leopard hiding, and there he is right there. It actually took me like 20 minutes to find him. He's well hidden. So take a look at this picture. Describe the color of those rocks. Can you guys find an animal that's the same color that's hiding in those rocks? I'll give you a hint. It is spotted, and it's a spotted squirrel. And there he is. Oops, past him. There he is circled right there. Our next one, take a look at these rocks and their color. Can you find an animal that's the same color that's hiding in these rocks? And it is a bird. So hopefully you found him and he's right there. Our next one, take another look at these rocks and see if you can find the animal that's hiding in them. And again, rocks are important because living things can use these rocks for shelter and to hide in. And so here is our moth right there. And my challenge for you guys is a rock scavenger hunt. See if you can find 2 rocks and fill in these sentence stems. So the color of my rock is blank. So use your eyes to describe the color. And then the texture of my rock is blank. So use your hands to feel those rocks and describe how they feel. So I'm going to stop sharing my screen. And just so you know, you can find cool rocks outside. I found this rock in my backyard. It has these 2 different colors on the inside and outside, and it has this weird little hole there. I also found this rock. It reminded me of a zebra because it has stripes. And this is one of my favorite rocks I found. It looks like a sunset. It has orange, yellows, and browns, so pretty cool color. I found this pretty pink rock. It looks like it has little white crystals in it. And this was one of my favorite rocks because it's shaped like a heart. So think about what are some cool rocks that you guys can find in your own backyard or at school. So we're going to go ahead and give it back to Mr. Broughton, and he's going to answer any questions.
Thank you, Mr. Ramirez. The question that came in was, why are rocks different colors? And rocks are different colors because they are made up of different minerals, which are different colors. And minerals could even be different colors because of how they form. If they form quickly or slowly, that could change their color. Or if they form under hot conditions or cooler conditions, that could change their color. So that they can be, because of really how they form is why they're all different colors. All right, now we're going to look at doing a scratch test with rocks with Mrs. Fuller.
Hi, I'm glad you asked the question about why rocks are different colors, because sometimes it's impurities in the rock that causes that. So for example, you're probably very familiar with quartz. Quartz is, it's like the second most common mineral or rock in the crust of the earth. The other one being this one, feldspar. This is probably number 1. The quartz is probably number 2. The quartz comes in different colors. For example, it can come in pink. This is rose quartz, and it's caused by an impurity, a metal that's in it. And they think it's either gold or titanium, some kind of really cool metal that causes this beautiful rosy quartz color. Another one, an example, is going to be amethyst. Here's a beautiful crystal of amethyst. Look how pretty that is. These crystals all have 6 sides. They're hexagonal, and that's because quartz and amethyst are in the same family. And the reason why the amethyst is purple instead of white is because of an impurity, in this case, probably iron. So there are a lot of different things that can cause that. Now let's talk about identifying our minerals and how we're going to do that. So one of the ways that we can identify a mineral is by a scratch test. Mr. Broughton just alluded to that just a second ago. So some minerals are one color when they're in their crystal form. This is iron pyrite. Miss Ramirez showed you that. This is what the crystal of iron pyrite looks like. It's called a peridotihedron. Isn't that beautiful? It looks like a rose. Well, I have a piece of iron pyrite that's all sparkly and gold, the kind that fooled the miners. I'm going to scratch it on this scratch plate. And when I do, when it's powdered, it's not going to be sparkly and gold. It's going to be a dull charcoal gray. Let me show that to you. Can you see that? It looks like a pencil mark, doesn't it? So when you use a scratch test on a piece of Iron pyrite, you get this charcoal gray mark instead of a sparkly gold one. So that's one way we can identify minerals is by using a scratch plate like that. All this is an unglazed piece of porcelain or ceramic tile. All right, let's look at another one. Another one, let's look at crystal shapes. Since we talked about crystal shapes a minute ago when we were talking about the quartz and the amethyst. Amethyst and quartz, because amethyst is part of the quartz family, have a hexagonal crystal. It's the way it's normally going to form. This is fluorite. We've seen fluorite a lot, and it comes in every color. Fluorite comes in every color according to the impurities that are in it that make it either green or blue, or in this case, purple. Look at that thing. Isn't it gorgeous? It formed an octahedron. I didn't cut it like that. That's the way it formed. Isn't that beautiful? That's a beautiful crystal. All right. Well, we're going to put the, I see I've got another crystal here. Oh, this is halite. Halite forms a cubic crystal, and it's got cubic cleavage. So every time you break it, it's going to form a cube. And that's because of the crystalline structure of halite. Another name for halite is salt. So you have a lot of halite at your house. You can take a little hand lens. I think I've got one right here. And you can look at it with this, but if you look at the salt from the salt cellar or the salt shaker at your house, guess what? It's all going to be little cubes like this. How about that? Okay, another one. Calcite. Calcite is in the shape of a rhombus, and that's how it forms, and it's got rhombal cleavage. So when you break it, it's always going to break into a rhombus. Another piece down here. Here it is right here. Look at that. Can you see that rhombus? Hold it up against my shirt. You can see that rhombus right there, just like this rhombus. And guess what? If it's smaller, guess what it's going to form? A rhombus. So that's a neat thing about calcite. Calcite's very useful. We have a lot of calcite in Texas. All right, let's see. What else do we have here? While we're still talking about crystals, I'm going to show you some granite. Mr. Broughton had a little piece of granite that he was massing for you. Well, here's a bigger piece. This is called basement rock. It's granite. It's from Oklahoma, and it's part of our continental crust. It's very interesting. And you can see all the different crystals in there. Crystals take a very long time to form. And so the bigger the crystals, the longer it had to form. So these crystals are not particularly big, but they're larger. You can see them with the naked eye. You don't have to use a hand lens to see these. The pink ones are this orthoclase feldspar right here. This is the most common mineral or rock in the earth. Rock. The black one's something called hornblende. The sparkly white one are quartz crystals. We've already talked about that. But the ones that look like glitter is something called mica. Mica is very neat because it's got cleavage also. It's got basal cleavage. Look at that. Isn't that beautiful? Almost looks like a big fish scale or something. This is biotite mica. And you can remember that because biotite and black both start with the same letter, B. This is muscovite mica. And this mica is silver. And that's what makes that glittery look in the granite when you see it. These little crystals of mica. And every time you break it, it's going to break off in these little flakes. Just like a little piece of biotite I had. Look how thin that is. Can you see that? That's how it breaks. Just, it's called basal cleavage. Very nice. Okay, and let's talk real quick about hardwood. Okay, now, there was a real famous scientist. His name was Moh, M-O-H. And he discovered that minerals have very specific hardnesses. And the softest mineral we have is one called talc. And this is what it looks like. Can you see how beautiful it is? It reflects light like mother of pearl. And so we say it's got a pearly luster, but it's real, real soft. It's so soft, it's what we make baby powder out of. Okay, the second one is that beautiful rock that Ms. Ramirez showed you, and that is gypsum. It has a hardness of 2, and your fingernail has a hardness of 2.5, so you can actually scratch it with your fingernail. Look up there. You see where I scratched it? How about that? So my fingernail is harder than this beautiful crystal. The next one, we're going back to our lovely calcite right here, and we can scratch it with a piece of copper. So I'm going to scratch it right here, and you can see where it scratched it right there, because this has a hardness of 3 and this has a hardness of 3.5, so it's just a little bit harder. So there are 10. There are 10 different stages, starting at talc and going all up to 10. 10 is the hardest mineral, and that is diamond. Nothing's in nature is harder than diamond. Diamond is the hardest. So those are a few ways we can test minerals to determine who they are or what they are. So I'm out of time, so I'm going to turn it over to Ms. Broughton if you have any questions. Thank you.
Thank you, Mrs. Fuller. We didn't get any questions for this part, so we are going to move on to sinking and floating with rocks with Miss Nash.
Yes, believe it or not, there are some rocks that float. Have you ever seen a rock that can float? Pretty amazing, but true. So rocks, a lot of rocks start in a volcano. So the volcano, like this picture here of the biggest volcano on Earth, Mauna Loa in Hawaii. Hot lava comes out from the center of the Earth, from under the Earth, where it's really hot. And when the volcano erupts, see what happens there. Up there it goes. Okay. So lava is coming out of the volcano and it's really, really hot, right? Really super hot. But once it hits the air or the water or the land, it begins to cool. And as it cools, it forms rocks. And depending on where the lava cools, it forms different kinds of rocks. So when the lava cools in the water, it forms a rock like this one called obsidian. See how shiny that is? It's sharp. It's really dense. They made knives out of it. Obsidian. If it cools on land, it's called scoria. And this one you may have seen around in landscape. It's got lots of little holes in it. It's hard to see because it's all black on black. The little holes, it's not terribly dense. Right? And then if it cools in the air, if it got thrown up into the air, it's called pumice. And you can see all the little holes in that one. And you can compare them and see that this one is light. And we're going to, again, use the pan balance. And we're not going to measure the grains, but we're just going to compare. So our 3 rocks are the obsidian, the scoria, and the pumice. Let's start with the 2 heavier ones. The obsidian, which one do you think can be heavier? All the way down. The scoria. The obsidian was actually heavier. So now I've got scoria and pumice. Again, which one do you think should be heavier? Can I guess? And the pumice barely made a dent. In fact, I can add some more pumice. Still didn't make it. Keep adding more pumice. Doesn't make much difference. So very, very light because it cools in the air. In fact, it's even light enough to float in water. I don't want my volcano to fall off on the ground. So you've probably done some little experimenting with sink and float. And you know that these two little balls are more or less the same size, a bouncy ball and a little piece of styrofoam ball. So which one would you predict would sink and which one would float? Let's see if you're right. Sink and float. The styrofoam is full of all kinds of tiny little holes, okay? All kinds of tiny little holes, and that's why it floats. So let's try it with our rocks. So got my obsidian here. What do you think? Sink or float? Straight to the bottom. Now the interesting thing, so the scoria has a lot of little holes in it also, like that pumice. Let's see. I'll show you. So when I drop it in, it sinks, but it's also giving off a lot of little air bubbles. Can you see the little air bubbles coming off? But the little holes had air in them, so the air is escaping. Now the pumice, again, has lots and lots of holes. So let's see what happens. And it floats like magic. Pretty amazing. More pumice, it's all floating. Floating rocks, amazing. The only rock that can float, pumice. We have 3 different kinds of rock. Can you remember the names? Pretty easy. So pumice can float, scoria sinks, and this one, this beautiful, shiny, sharp one, is called obsidian. So obsidian, scoria, and pumice. And again, the reason they all started out as lava, but the obsidian cooled in the water. The scoria cooled on land, and the pumice cooled up in the air. And that's why they ended up so different. So if you have any questions, you can ask Mr. Brown.
Thank you, Ms. Nash. The question that came in was, do any other rocks float? And no, pumice that I know of is the only rock that floats, and it's because of how it formed up in the air, like Ms. Nash just explained. I'm going to share my screen with you one last time to do a quick recap of what we did today. So today we explored properties of rocks. During this virtual field trip, students discovered that the natural world includes earth materials. Students observed and described rocks by size, shape, color, and texture. So first you saw me use some tools to study rocks. And again, those were a science notebook, a hand lens, a magnet, and a pan balance. Next, we explored color and texture of rocks with Mr. Ramirez. After that, we looked at doing a scratch test to find out the hardness of rocks with Mrs. Fuller. And you just saw Miss Nash show that rocks can sink or float, but the only one is pumice. Thank you so much for joining us this afternoon. We appreciate you taking the time to learn about properties of rocks with us. We hope you enjoyed this virtual field trip. You can let us know if you did or not by going to www.tiny.cc/EEC feedback and filling out a short feedback form. We hope to see you again after the winter break during our next virtual field trip for pre-K and kinder students. Have a great rest of your day, and we'll see you next time. Goodbye.